Welcome to Spring LIB.
We have a cord wrapped around this wheel here, and we're pulling on the cord with a force F, that is 40 newtons. The disc has a radius of 1/4 of a meter and a mass of 9.2 kilograms. And it's a uniform disc, so we're going to say J is 1/2 mr squared, and that is 0.2875 kilogram meter squared. So then Newton's laws just say that, the torque equals the force times the, torque equals J times alpha, and the torque is F times R because the force is always tangential to the radius, or to the point of application from the center here. And so we can then use, we know everything in here but alpha, so we can find alpha. The angular acceleration is 34.78 radians per second squared. Now the tangential acceleration at a point on the edge of the disk is just r times alpha, and that's 8.70 meters per second squared. So that's acceleration, in the tangential direction. I call it the theta direction because in polar coordinates you have r and theta. So you either have a radial or a tangential. So radial is r, tangential is theta. Now they ask us for the force, that's the reaction force at the hub here. So obviously this center of mass of this pulley this disc isn't moving. So we have some reaction forces here to keep it fixed. We also have the weight, and I'm assuming that this is in the vertical plane here. Obviously if this were all in the horizontal plane, then we wouldn't have a weight, but I'm assuming that we have a weight. Did they say it was in the vertical plane? I think they did. Steady horizontal pull. I'm not seeing it, but anyway, if it isn't, then W is going to be 0 because the weight is actually going to be acting into the page. Although then that would create an out of the page reaction. Anyway, we'll go with this setup. So there's no acceleration in the center of mass in either direction, so we have the reaction force in the Rx plus F equals 0. So Rx equals minus F, then that's minus 40 newtons. And then we have Ry minus W equals 0. So Ry is W, which is mg, which is 90.2 newtons. So the magnitude is just the square root of the sum of the components squared, and that winds up being 98.6 newtons. And then we can define the angle as the tangent of the angle is the r component divided by the x component, and that gives us that tangent is then 156.1 degrees. So from the positive x-axis, again, we're going to wind up over here somewhere, as we'd expect, because this force has a negative x component, and so it's going to be over in this direction, the resultant. And then what did they ask finally? Which of the answers in part A and B would change if the pulley were pulled upward instead of horizontal? Well, if we pulled upwards, then Rx is going to be 0. And then Ry is going to be the weight plus the force. So, Ry would change, Rx would change, and I'm pretty sure the magnitude here would change. That should change too. And then the resultant force would just be vertical here. And so the resultant force would be the weight, which is this, plus, so if it was pulled up, it would actually be if it were pulled, they say pulled upward instead of horizontal. So we'd have F plus Ry minus W equals 0. So Ry would equal W minus F. So yeah, that would be W minus F is 40, so we'd get 50. So we get a reaction of 50 because basically by pulling up, we're counteracting some of the weight with the rope, and so that the support doesn't have to do it. If we were pulling down, then that would be a different story. Then we're adding to the weight.